got to be careful with this one, okay, because there are some lines in this picture that look like they're parallel to each other, but aren't actually parallel. And there are some that look like they might be perpendicular, but aren't actually perpendicular. So what's the only way to really know for sure? Either write, well, not just write the equation, even simpler than that. What do we need to know about the equations? Yeah. Find the slopes, right? I don't need to worry about the full equation. I just need to figure out what's the slope of each one of those. Okay? So let's talk through that a little bit here. Actually, if you guys could, so I don't have to keep this up here, could you open your books to page 160 so you can see this picture in front of you? All right. So what I'm going to do is I'm going to unfreeze this. We'll go back to here. And I'm going to write down, for each line that's in that picture, we're going to copy down the coordinates of the 2 points that you have. So for line A in that picture, that would be the blue line. We got -1, 4, and 5, 6. For line B, we have the 2 points, -1, 1, and 3, 2. Dope. What? I said dope. Yeah, I did say that. For line C, -3, -2, and 3, 0. And then line D, this is the one that looks perpendicular, but let's double check. 1, 6, and 3, -2. Okay, so slope for each of these, what do we get? How do you find the slope between 2 points? It's a good question. Kind of need to know that. Who can help us out? How do you find the slope between 2 points? Yes, sir?
You add the two parentheses.
Nope, we don't add them. Yeah. You subtract, and then do what with the answers? You divide. It's the change in the y divided by the change in the x. Okay? I'll just put this down here. So, have you guys all seen that little triangle symbol before? It means change. Oh, well, here you go. Here's your first exposure to it. That little triangle means change in. Okay? So it's the change in the y divided by the change in the x. So just look at each one of these individually then. Okay, 4 is this y value. 6 is that y value. What is the change in the y? 2. Okay, so this slope is 2 on top. -1 is the x. Up to 5, what's the change in the x? Yes, 6. So I got 2/6, which is 1/3. Reduce that to 1/3. Okay, next one. What's the change in the y? 1. What's the change in the x? 4. So I got 1/4 is the slope for that one. Okay, let me step you through it one more time. Change in the y. Y goes from 1 to 2. So it changed how much? 1. That's where this 1 comes from. -1 is the first x. Up to 3 is the second x. How much did the x change? 4. So it's 1/4. Okay? So that's what we're doing. -2 to 0. 2. -3 to 3. 6. So 2/6. 1/3. Ooh, we got some parallel lines there. Okay, this one. 1 to 3. 2. Oh, my bad. I did that backwards. It's supposed to start with the y's. So the y, 6 to negative 2. How much did that change? Went down 8, though, right? So negative 8. So negative 8 on top. And then the change in the x, 1 to 3. That's 2. So this is going to be negative 4. Okay. So we have our 4 slopes are 1/3, 1/4, 1/3, and negative 4. Do you see any parallel lines in there? Mr. Ball? A and C. Okay. So A is parallel to C. And then do we see any perpendicular lines in there? Somebody who has not spoken yet. You have. Yes, you have. Don't lie to me. Anybody else? Where are my perpendicular lines? We have some in there. Tiara? B and D. Good. 1/4 and negative 4. So B is perpendicular to D. Okay? So there are all the parallel and perpendicular lines that were in that picture. Okay? There were a lot more that looked like they were parallel and perpendicular, but these are the only ones that actually were. Okay? All right. One quick thing I want to make sure that I talk about with you guys too here is equations of horizontal and vertical lines, because you're going to deal with those some here too. What way is horizontal? Yeah? This way, right? Left to right? So a horizontal line has a constant what value? X or Y?
Y.
The Y value stays the same, right? Okay, it's going the same way as the x-axis. I know that's confusing, but think about it. You just pick a Y value and then let it stay there, right? The Y is staying the same, okay? So horizontal lines are always Y equals whatever number you picked, okay? So it's always some kind of Y equals. And then likewise, vertical lines, vertical, yeah, I spelled that right. Vertical lines go up and down, right? And with those, what stays the same? The X, right? So it's X equals whatever that number is straight up and down. So that's always going to look like an X equals a number. Okay? So I'm going to plot a couple of lines, and I want to see if you guys can just use this idea real quick. Give me an equation for each one. All right, so let's say we've got this blue line over here. Oh, and assuming these are all, I guess, 1 unit. So there's 1, 2, 3, negative 1, negative 2, negative 3. Okay, so there's that blue line, and then do this red line here. So what is the equation of the blue line? We'll call it L. Somebody has not spoken yet. What is the equation of the blue line? You already answered a bunch. So have you. So have you.
I've only answered 2. I've only answered 1.
I know. You still have. Let's have Mark do it. Well, where is it crossing the x-axis? 3. So what should that equation be? Is it y equals 3 or x equals 3? X equals 3. So for line L, the equation would be x equals 3. That's it. That's the equation of that whole line. Okay. Using that same kind of logic, here's line M, the red one. Again, somebody who has not answered anything for me yet today. What's the equation of line M? There we go, Mr. McKinnon. Y equals 1. Yeah. Okay. And what do you notice about horizontal and vertical lines? They are intersecting, but more than that, perpendicular, right? They always form a right angle. So every single horizontal line is parallel to another horizontal line, and every vertical line is parallel to another vertical line, and they are perpendicular to each other all the time. So that's why I said you're going to have to deal with these in this section because we're talking about perpendicular lines, and hey, look, these are perpendicular. Okay, so that's how you can work with those. If you see equations that are written like this, okay, with no, y equals something times x plus something, if it's not in that kind of form, you're just looking at horizontal or vertical lines then. So just make sure you understand this little idea and you'll be fine. Okay, with that. Very last thing we need to be able to